Yeah.
Okay. First, I tell you again about outer material. Na? You are not getting outer material. Na? The skirt and berm.
Yeah.
Okay. Now see, we are one part rotated by 180 degree, and I need to print it. So what I do for printing, we are going to slicer. If we want to see what are the operations are, so we go for the slicer. Before printing, you can see how it is going to be printed. So go to slicer, and here I'm getting the settings of untitled. So if you want to change into configuration, go to configuration, and now here you can see the outer material. Infill, you understand, no? So here we are into print settings. Print settings, we have infill. This is the pattern inside the body. Okay. And the external fill pattern, this is rectilinear by default. So here we have these 5 types of shapes. These shapes basically outer material means the first layer and the last layer basically. Okay. Otherwise, all outer side you can see there is a rectilinear means just a single one by one layer. Now it will show only the single layer. Okay. But basically external infill pattern is visible on first layer and last layer only. See, this is the top one, this is the bottom one. You can change into suppose octagram into top, and the bottom I take in suppose concentric. Okay, now I'm going to save this one. Yes. Now if you want to see in this slicer, we have to on. Now here this is known as skirt berm. Okay, I tell you later again. Now we are going for, we have to see the range. Now there is no layer. This is only skirt and berm right now. If I'm talking to first layer, you can type here 1. See, this is infill pattern. No? I'm going to show you. This is first layer, octa. This is the bottom one. Bottom is the concentric we have taken. No? You can see in the top. This one, see, this is your final layer here. This one, the shape is changed now. See, here we can show you this shape. Yeah. This one. This is a different shape. See, this is not infill we are using here. I think honeycomb, and this is your last layer. See, this is in different pattern. If I'm talking about the below pattern, I can show you. This is the star one we are taking. Na? This is infill, and that layer is known as what we are taken into top, and what is we are taken into bottom, that is shown here, octa. Sorry, this is hexa. This is your first layer. Okay. So this is your top and bottom layer, and you can see from first layer and last layer here. Now clear?
Yeah.
If I'm talking about skirt and berm, you have to go to slicer again, go to configuration, and how many outer portion, skirt layers we required, loops required, or Birm loops required. So we can change into the configuration of the slicer. And I can see here skirt and Birm. See, we are taking three loops for both. Okay, so I'll show you that. I'm going to print it now. See, these are skirt 3 loop. I'm going to 0 layer. This one. They're the Birm basically. Okay. The 3 loops outer is Birm. Then we have first layer. If you don't want this is skirt and Birm, a single loop you require, same, we have to go to change in here. Single loop of skirt, single loop of Birm. You can save this one. And now you can print it again into slicer. See, now single loop is there. Clear?
Yeah.
This is a skirt and Birm. Now, for supporting thing, just suppose they're going to create a new part. I think in that those parts is not available. I'm going to create a new part which is maximum portion in the air. Okay. Now, first go to SolidWorks. Now, we are going to create like this shape. The first layer is on the bottom and the second layer we have into the air. So this type of shape we are going to create. Let's suppose the duct shape we are creating. Suppose this is a shape. Okay. See, when it is going to be print, the first layer is this. So that is basically when it is going to be print. This one is the in the air. Or you can move downside more like this. This is in the air now. I'm going to create this type of feature. Okay. Now suppose we have to print. This is in the bottom. This is into the air. We have to print like this. Let's save this file into STL format. The name should be part 2. Now close this here. I'm going to delete this part. Now we have to open a new part. Part 2. Okay. Now we have to rotate this by x-axis 90 degrees, like this. See, okay, let's try this portion in this. Now we have to print into the slicer. Go to slicer. Everything is okay now. We have to go to slicer directly, and let's see the portion is available in that. Supporting material is on or not. Supporting material is on. See, now into print settings, you can see the support material is on. The maximum is 40%, but taken overhand threshold. Taken 0, didn't require. Okay, now save this into the untitled. Save. Now this is our first layer. It will show you here, and then let's check. Supporting material is not there. See, otherwise it is not going to print now without any support. The supporting material is not working here. Here it will be available. It should be available here. Okay, let's go to slicer again and go to configuration of it. Generate material is on here. Let's see here all the things. We need to now part 2 is here. Generate material is on. Support material is on. Need to rotate it first. Rotate around x-axis 90 degree. Now it is here. Support material is on. That is okay. It is not working. See, here supporting material is visible in the adaptive layers. Is it visible now?
Yeah, how to do?
See, that is visible into adaptive layer, not in the part directly. Okay, we have to go to adaptive layer, and here it is visible. This is a supporting material. Now, from where we have to go? This is into the slicer basically. We are into slicer. Okay, go to its object settings. Okay, here you can see into the adaptive layer.
Only we can see that place only, yeah.
Yes, you can see here in the adaptive layer.
Not home page we can see, yeah.
Yes. See, this is adaptive layer quality. 75% we already did now. When we have pintang setting, we are given. We are not changing this one. Okay, so here we can see all the layers. Whatever you see, the star is available now. So you can see this is the star layer. It is the infill. And here, this is our first layer. Sorry, this is supporting material. That is honeycomb is there. And you can see this is concentric. We are applying on the first. And on the top, we are given different shapes. See, this is available here. So overall, star is visible. Yes.
Yeah.
So you can see all the layers like this. If you want to change this, this is not honeycomb. You want to give it the pillar. So we are going to change into pillars first. Supporting material. And you can see pattern is the honeycomb. It changed to pillars. Now go to object settings. You can see here in the adaptive layer. Pillars are not. Yes. Now see here it is in the pillar format. This is separate pillars are created. See, see here it is separate pillars are created. Okay, the pillar format. Want to change it? You can change it also. I'm going to change it by not pillar. It is a rectilinear. Then to change to settings in the adaptive layer. It is now rectilinear shape. You can see the simple rectangles are being formed. Okay. So everything you can see here. All the layers, all the settings you can see into the slicer settings of the part. Okay. Now any doubt? If something is directly on home page not visible, so we can see all the things into the settings. It is going to be created basically like this. Similarly, if part we are choosing the different part, there also you can see. Now I'm changing the part, suppose. Now this part I'm going to delete. Now I'm using different part. The part table, suppose. And here also supporting material required. See, this is in the taper format now.
Yeah.
Or we can rotate it about x-axis. Or we can do this portion into slicer directly. All the things. You can add your part here. Oops, that part is not available. Table here not available. Na? It is a demo. That is not visible here. Second. Oops, sorry. This is not available there. Where it is saved, this is into the printer directly. Na? We are not created it. So I'm created. I show the format here. Go to configuration and use different parts. Add here part 1. You see, when you are going to print this part, and here also we require supporting material when it's going to be print. So all the printer we are taken untitled. Okay, go to the object settings. Select your object first, then go to object settings. In the adaptive layer, you can see the supporting material. See, in holes also supporting material required. Visible?
Yeah, what is that?
Sorry?
Extra material, supporting.
This is supporting material. This green color is a supporting material. See? In hole also it is required. Okay.
Yeah.
This is how we can print.
So how to remove that extra material?
Here we can't remove, na? You have to remove the extra material after printing. In 3D you have to remove, na? You have to give into the soluble material. The part you have to insert into the soluble material where this is going to be soluble, and you get your PLA material only. PVA is going to be soluble. It is going to be melt in the particular, you can say, this material is going to be melt with that material. I show you the that video, na? Here the part is created with the supporting material, and we are dipping into one chemical, and that is the dissolve, and the part is only remains the same. Okay, I show you that also again. Wait. See, these are supporting material are there. Here we are supporting material. So you can see into the video first. See, manually we can also remove, or we can see it is in the manual removal. We have to take a cutter and we have to remove that, and then we have to finish our part. This part is going to be created with the supporting material. In the pillar format, it will create. Na? By using these cutters, we have to remove that. See? So we have to extract our extra material like this. This is the one kind. See, why they are using this one? Because of we are using single extruder printer. Okay, so both material are same right now. So we can't dissolve into the material, into any liquid. There the PVA will be dissolved. But here we are using only one material, that is PLA, because it is a single extruder machine. Okay, if you are using 2 extruder machine, 3 extruder machine, then we are using 2 or 3 types of materials at a time. Okay, so then we give the support material should be of PVA material. So in that case, we can use the chemical where the PVA will be dissolved. Okay, so that manually we didn't use this, but in general cases, we are using single extruder printer. When we are using single extruder printer, so both material are same. So we have to extract manually only. Okay, and then you have to give to finishing to our part. Is it clear? Any question, any doubt?
No. Okay, that's why this right now we are using DMLS. Maximum we are using this technology because here we didn't use any extra material, any support material. Okay. Yeah.
Because it is a powder based technology or laser based technology, it will create directly the part and finish the part. Even layers are not also visible in that case. But which type of printer generally we are using in the as a learning purpose, that is FDM technology. In this we are using layer by layer like this. Okay. Now after this print setting, we have some filament settings. In the filament, which color you are using in it. Suppose I'm using the new one. In this filament color is white. You can use color, different color you can use into the filament. Then the diameter of the filament. So that is we are using into our printer 1.75 mm. How many extruder are there? Only one. Okay, what are the temperature of the extruder of first layer temperature and the middle layer? This is a bed temperature basically of first layer. So that material going to be add on into the bed. Okay, so that should be more than other layers. So generally we are using 220 and 60 of the bed. 220 for the extruder and 60 for the bed. Okay, or if you have density of the material, you can provide a density also. These are optional. Then cooling period. So we have to give the fan speed. See in how many minutes it should be converted into solid. Okay, so we have to give that particular fan speed. For first 3 layers, see it is disabled because it takes some time to convert into solid. Otherwise, it is not. If we are giving the cooling to our first layer, second layer, and third layer, that means it is not fixed with the bed. Okay. So that's why the below 3 layers are fan is not working. So that they are properly set to the bed. After that, we have to give the fan speed. So that minimum and maximum you have to provide in how much time you want to fix into solid. Okay. Now we have to get it our G code file. How we get the G code file? I show you into the direct Revit IR host. Okay. And then if you want to type some notes here, you can type the notes. If you have some override, some capital printer are there, so you can volumetric speed you can increase if you want to override. Otherwise, that should be optional. Generally, we are not giving this one. We are generally using the same speed we are applying here. Okay. Then we have printer setting. So we have to set the bed shape. We already did these settings.
extruder, how many extruders are there. Okay, if you connect your system with your printer, so you have to give the USB connection there. Okay, if you are using with the server, you can go for the host type. If we are creating the server for the printer, how many laptops are there which are connected to same printer, so we are creating the server there. Then you can use this server portion. Otherwise, generally what we are doing for education purpose, we are using generally the printer and converted the file into G code and give it that file to our 3D printer for printing. Okay. So here generally we are learning two softwares simultaneously. First is Revit host and the second is Slic3R. Okay, there not too much settings are there into the 3D printer. Just we have to give the same printing settings are there, and we're going to save this. And now suppose for this you want G code file. Okay, so here you have to go to SD card, print preview, and I need complete code for this part. It takes 4 hours 31 seconds, 31 minutes 11 seconds. Layers are there 460 for this part. Okay, now we have to print this. So for printing we are need one G code file, because our 3D printer understand only G code file. Okay, so we have to convert this file into G code. So here we have save to file. When we are going to save from this portion, it is saved as a G code. See, you can save your file into G code, and then we are taking this file and give the printing portion into our 3D printer. Okay. Clear?
Yeah.
You can save this file. Now I can show you that file. If you want to see the G code of this file, basically the program in the sense of programming, you can say, you can see your G code file here. See, this is your file which is understand by 3D printer. This complete file. How many steps are there? You can see 53,954. This is the file which is understand by 3D printer only.
How is that created?
Just we are giving the save file. Na? The Revit host is already created this.
We cannot run that create.
Sorry?
We cannot run or anything can do. How to G code created?
See, just you have to save to file. It is created the G code file.
We first we do all settings, then
we have to give all the settings first into the printer setting, into the print settings. Okay, how to object placement. After this, we have to go to print preview, and here you need to save your file into G code. Okay, so that you get your G code file, which is basically this file. It is generated by Slic3R.
We cannot give any. We cannot give any offset to filament on base plate. Anything we can do.
Sorry?
We cannot do anything for offset filament plate, base plate. We cannot do anything. But how to save that?
We did all the things, na? We gave bed temperature, we gave the extruder temperature, we did the filament color also. All the things we are given na, into the printer setting.
That okay, see? But the movement of filament we cannot give anything. La.
So it will create by the settings we are giving na. See, we are giving first layer is rectilinear, so it is started by origin where we have placed it. So printer first point will be this point. Okay, then it will be going rectilinear motion. We are giving to our printer setting. This motion we are provided na. This type of printing we required. The star one we required. So we need to give the star there. Okay. And we give the temperature there. How it is set. Yes.
We give setting as a shape, thickness. We can already we done means it automatically G code format.
Yes.
It
See,
based
all the
on
things we are given, it is taken here. See, it is external parameter extruder width is 0.4. We are giving 0.4 mm thickness. The inner extrusion width is 0.56. It is already created by the software, that is Revit host or Slic3R. Okay, where we are using M107, G92, E0. These are the settings about your printer only.
okay.
Where we are going to lift your nozzle. See, first layer is complete, so we have to lift our nozzle towards X, plus Z axis. Yes, so that is lift by the printer settings. See, first we have to go to the home all. See, these settings we also provide to our printer also. When I show you the printer, then I show you the home screen also, where we set the nozzle, where we set the origin, where the starting point is. Okay, that based on the part basically. So we have to give these all options also into the 3D printer. We are giving the preheating first, so that the printer get the temperature that's 220 degree, so that the filament it will be melt. Okay, so we have to give that all option into 3D printer also, so that it is working. Then it shows XYZ locations and it's going to be print. Okay, layer by layer. Clear?
Yeah.
This is how we get this file. After that, we are going to 3D printer. So today I don't have 3D printer right now. Okay, so you have to practice till now here. I show you all the settings of the printer of the software. There is nothing left into the software basically. The software is very small here. We have to give the printer settings and print settings. When it is done, we get our G code file. Then you have to save this file. Here it is. We save that file into one folder, and the G code file is G code Revit host file.
Other software are not Revit router, we cannot create it.
Sorry? This is the G code file we are created. Part 2. No, let's create it for table, no? I think.
Yeah.
1 second. Let's check again. The file name. Save to file. It is the same file. Okay? It is a part 2 name. And it is created at 11:47. Yeah, this is the file. 11:47. This is your G code file.
You can be saved to SD card, it automatically to connected.
Sorry?
We can save this file as SD card, it automatically to connect printer.
Yes. We have to save. Now this file is here. If you connect the SD card to your laptop or your system, you can save into the SD card also. Okay, save the G code for direct print. You can save your file into the SD card and then take the SD card and attach with the 3D printer. Okay, so tomorrow I show you the 3D printer and how it is going to be on, how it is going to be working, where the nozzle, where the extruder. I show you all the things into the 3D printer. Okay.
Yeah.
Tomorrow we are on video call basically.
Only we create a 3D model in other software, not this Rapid roster we cannot create. Hello. Hello.
Yes, you are asking something.
Only we create 3D model in other software, not cannot be create in Rapid roster.
No. Here only you can add the product which is created through any other software. That is converted into STL also. Okay. See, here you can load only. When you are giving the load, you can see here you can load G code file or 3D file. See, generally we are using here STL file. So you have to create your part into any 3D modeling software. Then you need to convert into STL. Then you can attach to our Revit host and give all the printer settings to our part and see how it is going to be print. So layer by layer we can see that thing, how much time it will take to print, how many layers, how much filament required. See, here required 25, approx 26 meter filament required to print this part. Okay, if we are giving the infill pattern, this one is in lower range. Basically, you are giving the gap inside it. Okay, it is not give you less strength, so it will take less material. It will print into less time. Okay, that is, I tell you all the things about the printing.
I want out.
Yes.
We can use more layer of filament and less
Sorry?
number of filament. We can use both more number of filaments layer and less number of filaments layer. What is the advantage of the difference?
Sorry, again tell me.
We can
Where
use
it is?
more layer of filaments. Yeah.
More layer of filament. Okay.
Same wise we can use less number of filament for time saving. What is the advantage of more filaments we can use and less filaments layer we use?
Basically, it is depend on strength, na. If the layer are less, means you are created the more height. Okay, you are creating 1 mm or 2 mm height to the layer. That means material is provided there less quantity. Okay, the layers are less. That means material are less. Material is less means strength is less. If you are giving more filament, that means you are creating a solid body type. It is a more strength. It give you the more strength to our part. That's why it's taking more time also.
Yeah.
That is created through then slow speed also. Okay. That is the advantage. If we are giving more material, that means our part is more strength.
Another doubt, we can place the executor in that machine. Okay.
Sorry.
Extruder.
Extruder, yes.
That placed in the printer machine. Two extruder we placed. Okay.
See, that is basically depend on the printer. How many extruder are there?
Yeah, but if I placed in 4 printer, okay, four extruder, okay. We can use this or setting. We can put two means only work.
Your voice is not clear. It is breaking.
Hello.
Yes. Tell me again.
We have a printer machine have four set of extruder. Okay.
Okay.
But we can Rapid Oster. We can use only two extruder. Then it apply printer machine means it can take only two executor. Another two
Hmm.
is stock.
Yes. See, in this rapid host, we can see three extruders. Or generally, maximum three extruders are there in the 3D printing.
Yeah. Okay.
Okay.
Same like
And this is basically used in FDM technology, where we are using PLA filament, na? And the extruders only we are using one or two generally. Even they are not using three also.
Okay, but we can use one, but available three executor in machine means to work only one.
No,
That
you
only.
can simultaneously you can give the three extruder, na? See, we are going to printer setting. Let's go into the printer setting. Here we have extrusion multiplier. See how many extruder you have? Four extruder. You can give the four extruder here. Extrusion multiplier. Or if you want to printer settings, extruder. How many extruder are there? See how many capability of extruder you have. You can give every extruder different
Sir,
setting. Okay. Suppose you are giving first extruder setting. The it is do after is 0 0. It is started from the origin. Okay. When it is completed, its layer, then you can use second extruder and you can start from the same location where the first extruder ends, so that we can create the multicolor object. That's why we are using extruder on multiple extruder. Otherwise, there is no requirement. If you want to create a multi-extruder portion, that means you are creating a multicolor object. Okay. So see in the Slic3R we have multiple. How many extruder you have? You can try use that one also. Okay.
but asked only one thing. We can use some other setting, but machine printing setting some other. We can use bothable are attached to work it or not working. Yeah.
Yeah, working. I show you the video. Two extruder printing. Now I show you that. See, this is two extruder printer. See, the same size of bed is there, but here it is two extruder. See, behind that you can see here single extruder printer. Here it is two extruder printer. Here we apply two filament separate here. One is right now, it is one is working, one is stopped. See, at a time you can print two with the two extruder also with different color. See,
We cannot nozzle and that plate offset
sorry.
the distance. How to we can measure that? Extruder and base distance in starting RG.
Your voice is not clear, Sanjay. Please come in the network. See, this is two extruder print in one object. This multicolor basically.
That is extra supporting material.
No, it is an egg of that. You can show that also.
What is that orange color?
Sorry?
That orange color extra material.
No, you can
Material.
use you can use as a supporting material also, or you can use as a second color also.
If supporting material with different color means we can extra extruder we needed, yeah.
Yes.
If supporting,
If you want to supporting material, you want to use different color, so you need to use extra extruder. If you want a supporting material with single extruder, so same color will be there. If two extruder are there, then you can use the two different materials also, like PLA and PVA. See, this is two color print.
yeah, I have one doubt.
Yes.
We have base plate, okay. Then extruder distance nozzle of that origin to that plate. How to calculate?
Your voice is breaking, Sanjay.
Hello.
Tell me again. Yes.
We have base plate in layers, okay.
Base plate and layer, okay.
Then we have extruder nozzle distance between that plate to that nozzle. How to that origin? How to calculate and retraction that we how to
See, when we
calculate?
are going to place, when we are going to place it, we have to set the origin to our 3D printer. Okay, when I show you the 3D printer, I tell you that how to set the nozzle on the print and what is the gap between the nozzle and the bed. Okay, that is basically that distance will be as thinner as we have a plain paper of A4 size. Any paper you are taking, just we have to give a small gap so that that paper should be passing through between the bed and the nozzle.
Only physical
it is in physical.
Okay.
We have to maintain our bed height and the nozzle height manually.
We have no option to Revit Architecture to distance calculator.
We have the option, but here we have only origin we need to set x00. Okay, that position is at the center. Here x0 y0, it is a center point. So we can set that position so that nozzle start from here. But when we are giving the print, the nozzle start from here, but material should be provided where we have the material available on the part. First nozzle set at this position. When it starts printing, it starts printing from this side. It will take from the G code. Okay.
Retraction.
The nozzle first nozzle position we can use at origin 0, 0, xy 0, 0, and it is taken second position from where it is going to be start. It is taken from G code file. Okay. Similarly, in the rapid tire hose, we are taking 0, 0. Similarly, we are taking 3D printer as 0, 0, so that both positions are common. Okay.
Retraction. Retraction.
Sorry, what?
Retraction.
Retraction means?
After one layer completed means to remove to return to some distance and then again to another layer create that gap between
Yes,
nozzle.
that is a travel basically. So nozzle automatically lift up and then move to the second position and then start it again. I'll show you
uh,
here. 1 second.
it automatically calculate.
Yes.
We can
With, with,
only
with the help of G code file, it will start. See here, it is a show travel move. You can see this is traveling of your nozzle. So that little material will be there, na? Because it is simultaneously melting. So that if we are working with the one layer,
so we can use only origin point. We can physically to
side of the origin. See,
okay.
here it will take origin this one. So that now nozzle is moved towards the first location. So it will give you some material that is extra. Then it is see when it is created one layer, then it is a movement like this. See, this is extra material we create. This is not the layer part basically. This is you can see into the show travel move. The printer is going to be like this. For a single layer, see, first here completed, then goes here, then here it is print, then goes here, here it is print, then goes here. Like this, it is going to be print. Okay.
Then printer setting and rapid oster printer setting also different means if nozzle dia 0.5 mm mean printer machine, but we
Hmm.
can give rapid oster nozzle dias 1 mm means it working or not.
No, it is not working.
So based on machines we have required, that only we can printer setting also rapid oster.
We have two same settings we required. What is available we have into the 3D printer, we have to give the same setting to our Rapid
Rapid.
Arrow for
Okay,
creating our G code file.
okay.
If there are two extruder, you need to type here in the Rapid Arrow, two extruder are there. Different colors, you have to take different colors. If there is a nozzle dia is 0.4 mm, you have to give here 4.4 mm. So that you get exact time, exact filament required. Otherwise, both are things different. Na? If you are
Yeah.
giving here 0.5 into the rapid eye host, okay, it calculates through 0.5. So it takes some time, less time as compared to a 3D printer, because in the 3D printer there is 0.4 mm. So it takes more time to create our part. It takes more filament. Okay, the number of layer are different. So we have to take same things. If we have 0.4 mm nozzle, we have to give 4.4 mm nozzle. Clear?
Yeah.
Now try in your system first. Do the practice. If you have some doubt, you can ask me. I'm here. Okay.
Yeah.
Okay. And tomorrow I show you the 3D printer.